He should be on. I sent it to him.
Someone upload this.
Oh, that's what I had on my computer.
Terrible idea.
That's why I already did this.
That's why I don't exceed bodily fluids. All right.
Further, he wants us to review test results. We can just talk about
Yeah.
it. I don't know if you have an official scrub.
Hello.
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 That's awesome.
Can you hear me all right?
Yeah.
Excellent. Cool. Nice looking rocket.
Thank you.
Yeah.
So
That would be good.
We're gonna bring
Cool.
the camera here closer.
Just while you're getting set up there, sorry, I sent you just last minute agenda. I realized I hadn't sent it through earlier, so sorry about that. But essentially, I'll get you to show me over the rocket just as a whole. Then we'll start at the booster end and work our way up, and I'll just look at all the little bits. Just reviewing your technical report. That all looks fantastic. So cool. I do have a checklist I'll be looking over, so I'll be looking away a fair bit just to make sure I've got everything. For you, would you happen to have a mobile that can join the Zoom as well?
Yes.
Yeah. That's good. That's good for close-ups. So
Yeah. Healy, who's in the Zoom meeting, will be doing that.
yeah, cool. If you want to prep that, I'm just grabbing the checklist. Sorry. So I'll get you to start with just an overall of the rocket. So the looks pretty good from here, and I've seen from your technical detail, it all looks good from a safety perspective. So we'll just get you to run over it and talk about particularly just start with a general overview up the rocket, and then we'll go back to the booster and get into a bit of detail.
Did you have any general?
Yeah.
Okay.
Cool. Just give me an overview of the design of the rocket and how it was built. Yeah, just to start with. Yeah.
Sounds good. Should we introduce ourselves first?
Yeah, go for it. Yeah, if you like.
That's so funny.
I know.
Yes, you go first. You're...
Okay. I'm Keely.
Okay.
Go ahead. Okay.
Okay.
I'm Thomas. I'm the launch operations lead, so pretty much the thing can and aerostructures.
Nice.
I'm Ishan. I'm the safety ops lead for the project.
I'm Alex, payload.
I'm Daniel, and I'm the recovery lead.
Yeah, perfect. Cool.
All right.
All right. Yeah, so just I'm going to move you to another screen, so I'm going to stop looking at you just so I can get a better view. Yeah, use the mobile if you can to just walk me across the video and talk me through it. The rocket, sorry.
All right.
Do you want to mute the mic on the laptop?
Yeah.
You'll have to turn this on.
Oops. Oh gosh.
Okay, can you hear us through this?
Yeah, yeah.
Looks good.
Okay. Oh yeah.
I need to hit escape.
So starting with the aft end of the rocket,
Yep.
this is an ultimate Wildman kit from Wildman Rocketry. It's
Perfect.
oh, is it? Oh, okay, okay. It's not too different from what the kit normally comes with. It's got the same set of fins. It's got the same size booster section, switch band, upper body tube is a little bit longer. And then we added a coupler and a nose cone, but I'll get to that as we get further up. So starting from the back, we're using an Aeropack motor retainer, the motor retainer set. And then we have our motor casing and hardware in here, which I guess we'll go over when we start breaking into the fin can. We're using, I guess for us, these are regular rail buttons. I forget what the designation is. These are unistrut. We have our first bottom vent hole. We have two. Or the others, I guess, out of view. They're just 1/8 inch for this section. Going up, this isn't actually a split in the rocket. It's just a coloring split. This is all still part of the booster section. This is our second rail button.
Yep.
And then going into it, this is where our first break in the rocket is. So we have two 440 shear pinholes on either side of that for a separation event here. This is the switch band for our avionics bay, which is 6 inches into either side. So it's a little over body tube.
Yep.
Then this is our first bolt. This connects our upper body tube to our AV bay. And we have 3 of those around the rocket. We have 1 in place here just to keep these 2 sections together as they would be in flight. This joint doesn't separate. Moving up, we have our main parachute in here.
Yep.
And then we have another set of shear pinholes. So currently we have 3. We're looking to double that because I guess we'll talk about this later too. We had a problem with our nose cone separation at our last launch.
Right, okay.
Then we have a second coupler, which we added, or excuse me, a second switch band with our upper coupler to add room for our payload experiment, which kind of sits maybe from here all the way to here, maybe a little further in. Yeah, so I guess you can't see my hands from there, sort of to there. And then we have the standard nose cone.
Yep.
And it's aluminum tipped, but all of this is wound fiberglass. And then this is just a paint job on top of it, but it's the stock fiberglass that Wildman uses. Is it G10, something like that?
I think so. I think G10.
But yeah, it's spiral wound fiberglass.
Yeah, cool. I'm happy with the material. I know that kit quite well. Using the kits make my life a little bit easier. So
Yeah, they've made our life a bit easier, especially like this being our first year in Spaceport. We wanted to go with something reliable. Then we also had me and another member who are L3 certified that use Wildman kits, so we had some familiar people.
Yeah, I used Wildman tubes on my 8-inch tubes on my L3, which is they're just great. They work nicely. Cool. All right, going back to the booster.
All right. There,
So can you just show me a bit closer up with the thrust plate?
Oh yeah. So
cool.
Like we said, this is the Aeropack regular thrust plate. At the moment, we just have it in with a single screw. So the largest novel part of our design is our thrust plate catch. So we have a 3D printed part inside of here that catches through bolts here and also holds our rail button. That's supporting the fins, supporting the end of the motor tube, and then keeping everything in line with itself, like keeping everything concentric, and then allowing this thrust plate to stay in. So I'll take off the rail button and show you what that part looks like.
Yeah, cool. Thank you. That'll be good. And that's printed with.
It's printed with PLA 95%.
Yes, yeah, it's extremely dense plastic.
Is it so yeah, I'll wait to see. Yeah. Cool.
So this is the first iteration that we had. We're looking to print another one by the time we reach Spaceport, but it's got a whole bunch of heat set inserts. So for screwing through the body, we used 1024. And then for the rail button, we used quarter 20 just to make sure that it was beefy enough to receive this. But it goes in this orientation and it catches all the fins to make sure they're evenly spaced and then keeps everything perfectly centered. And this is just an alternative to using the provided centering rings for the rest of the motor tube that the Wildman kit provides.
Yeah. Cool.
Yeah. In some flight
Um,
testing.
Sorry.
Oh, sorry. In some flight testing, with my L3 certification, as well as one of the launches we had, we experienced some damage to the interior of the fillets. And this allows us to be able to very easily access those interior fillets, repair them, inspect them before each launch. Because it's completely removable. With a permanent attachment joint, it would be very difficult to get to that. And that's kind of the main advantage of this and why we chose to do it.
Yeah, perfect. Yeah, I'm happy with the design. Are they touching the motor tube, the motor mount?
Yes.
So you've flown this before?
Yes, we've flown this
This
twice now.
configuration? Yeah, cool. Are you seeing any heat damage on the internal?
Actually, no, not at all. We haven't had any
Good.
problems with that because we've been using the Aerotech. Well, we've used a couple different casings. The first launch, we used a 78 millimeter motor, even though we have a
Yeah,
98
cool.
millimeter motor tube.
Yes.
And we just used spacers, so that didn't have any heat damage. And then just this past launch, we used a 98 millimeter 3-grain motor, an M1600, and that also showed no heat damage.
Yeah, cool. All right. Cool. The RSO on the day might pick something up on that, but for me, I'm happy with that. The only issue I can see there is if there was heat transferred and you've got the heat inserts, it might cause some movement, which could loosen the whole thing.
I see your concern.
What's your so I'm just trying to think this through, where else it could be an issue. Your booster separation, what's in between the motor and your booster separation charges? Is the top of the motor exposed to the pressure of the separation?
Well, we're here. We have our motor casing to show you. So it's exposed at the aft closure, and this is a 3-grain. Oh, excuse me. Sorry, forward closure. This is the 3-grain case. We don't at the moment have the 4-grain with us, though the club does own one. But it does use the same forward closure, so that is exposed, though protected with.
Are you retaining at the top of the? Are you using the top retainer for your recovery on the motor? Is that where you're tying your anchor point, or you're somewhere else?
So, yeah.
Sorry, I'm jumping ahead a little bit here. That's why I took a few seconds to gather my thoughts. But yeah, it's just I'm just trying to think of every scenario with those 3D printed thrust ring retainers. That's all.
Obviously you
they
can't
don't look
see
like
it
they're
because
receiving any heat damage, but I'm just a little bit worried that I'm just trying to think for every scenario where it could cause an issue.
I'm sorry, I had missed a little bit of that.
I can see that the your thrust ring anchor points are not receiving too much heat damage, but I'm just trying to think for every possible issue that could come from that. So just to make sure.
Yep.
Yeah.
There are 2 layers of centering rings between where the charges would theoretically reach.
Yes. Yeah. This the thrust plate isn't the only form of retention we have on the motor. We have 2 fiberglass centering rings here and here, about that are capping off the top of the fin section. I guess they are just a little bit lower down than that. And those are like fully epoxied on either end. And then this is sealed, like this little section up to the top of the fins is flooded with epoxy. There's a thin film that's keeping that there. So there isn't like clear passage from the ejection charge to the thrust plate catch.
Yeah, no, what I was worried about is the pressure from the separation charge pushing back on the motor case, which will then, if those retention points have melted, it could push the whole motor out if you think of it that way. So it'll push your eject your motor out the back, which would definitely be a safety issue. But what's the so you flew an M1600? Did you say?
Yes.
The 3 grain, and the 4 grain you're going to fly is an M19 something, or
it's an M1939W.
Yeah, cool. All right, let's move on. I don't think I need to dwell on that too much more. I think I'm okay with that. I'll just put a note on there just to say, I'll just put some of my notes on there just to say that I'm happy with it. So, just based on the fact that you've flown it before and that it doesn't seem to be too much heat transfer into that 3D printed component. So, yeah. Cool. Anyway, let's move on back to the booster, if you don't mind. I just want to. Can you show me the internal fillets?
Yes.
So, yeah.
I guess those are kind of hard to see. Does one of you have a flashlight that you could?
That's good enough for me.
Okay.
Yeah, that's perfect. So, and you got your external fillets.
Yep.
Do you have?
So these are. Oh.
Sorry. Do you have? Are you doing tip to tip on that, or is it?
Yes, this is all the way
layups
from both ends.
Yeah, cool. Do you have fiberglass layups on your fins, or is that?
No, we don't.
Yeah, that's cool. So that was just leading in my next question. I was going to put the both of them together. I just wanted to talk, ask you about your surface preparation and what steps you took.
Yeah, so having the two L3 people, we did encounter problems with not sanding enough or gritting up a surface.
Yep.
Yeah. For like epoxy separation and cracking, and then also like pouring depth. So as far as preparation goes, these come with like a caking agent for when they come off the mandrel. So first step in prepping them would be to give them a full scrub with like a Dawn degreaser soap and Windex, just to make sure that they're nice and clean. And then we went with 80 grit sandpaper to really make sure we had a nicely scored surface. And then the call out for the BSI epoxy that we were using is no more than 1/8 of an inch pour depth. So this isn't like the full depth of a pour. This actually has some Bondo on it to fill it out. But those were the rules that we followed with. And then we were also mixing our epoxy with milled fiberglass.
Cool. All right. And your internal fillets, were they
same process?
Preparation? Same process? Yeah, cool. They're the ones that actually take the brunt of the load anyway, your internals. The externals are, take less. So, yeah, I'm happy with that. Cool. All right, let's move up and look at your aft separation. Actually, before you do that, just the rail buttons, the location. Where's your CG?
The center of gravity is, I believe it's around here. We don't have markings currently. We've been looking at printing out our decals.
Yeah, cool. That's fine. Cool. So your top rail button's a bit lower than your CG. Can you?
Yes.
Obviously, it's right on the coupler, so I'm not expecting you to have to screw it into the coupler. But yeah, if you can talk about why it's a bit lower. Where's your coupler end? There.
So the coupler is like right about there on either side. Cool. It's a 16 1/4 inch coupler, and then this is a 3 inch switch band. So just imagine that split on either side.
Yeah. So why is the so just talk me through the positioning of your top button there.
Button. So we were fighting like the normal, keeping it too far back to keep rail stability but also wanting it forward enough that it can like hold itself up and not necessarily be like a cantilever beam on the rail.
Yep.
So we had picked a nice middle spot between where our advising professor, who is L3 certified, had placed his, and then where both me and the other L3 certification
Because,
had placed theirs.
yeah, because of the
Perfect.
long forward section and the weight in the nose cone, our CG is much higher than those other two rockets. And so it's 96 inches from the nose cone, which is around here. And so this is a very close approximation of that CG, which means it is very controllable on the rail and very easy to get on the rail. We're not worried about the rocket not being stable.
Yeah, perfect. Thank you. Yeah. Cool. All right, let's have a look at your aft separation. So I'll get you to just separate the rocket and show me as it comes out.
Well, that one's on. But...
Try it. Come on.
Cool. All right, you can set the booster down. Cool. Just remind me, this has been flown before. You had a problem with nose cone separation, but not the booster. Is that correct?
Yes,
The
so
booster
I
has been
said
flown?
nose cone separation problem. That wasn't that it didn't separate, it was that we had an extra weight and then not enough shear pins, so it separated early. We haven't had any problems with
Okay.
coming apart upon ejection charge.
Yeah, cool. And your
Who's talking?
sorry, what was that?
I think you were saying.
I can't remember. Sorry. I think it's okay. What I was about to ask was your shear pin calculations, and just talk through how you got to 2 shear pins.
Yeah, so the big driving factor for our 2 shear pins was more so drag separation than anything.
Yep.
And
On this section.
yes, on this section, which is why we only have 2 of the 440s. We did a little bit of calculation as far as pressure. We have like access to an online calculator on that, but we also ground tested it twice, I believe, before we ended up launching. And it worked very cleanly. And under the advisor of the Rocketry Club, we weren't worried about flying it with 2 shear pins and then having a drag separation problem prior to apogee or around apogee.
Yeah,
One of our prior experiences with this kit was for an L3 certification, and we had more shear pin. It was the exact same Wildman kit except with the original shorter payload section, and that one had more shear pins in this separation point right here, but it ended up having some issues in launch and separation. And after talking with Ben Russell, who's a big advisor for us, he said that you really only need 1 or 2 in this section because we're trying to prevent that drag separation. Really, other than that, the section doesn't really have very strict pressurization requirements. For shear pins, that's to break like the forward separation.
Perfect, thank you. Is your drag chute currently packed as it will be on the day? Can I get you, if so, can I get you just to pull it out, or just want to see it coming out of the tube, essentially, just to make sure it's...
So this is the drone chute and its chute protector. And then we have full 40-foot length of shock cord in here.
Yeah, cool. All right, so that fit out nicely.
With a bridle swivel at the top of the fin can right here.
Yeah, cool.
Yeah.
Are they sewn knots or are they tied?
They're tied knots.
Cool. Have you done any calculation on the load strength for those knots?
Well, we're using figure 8 knots, which is a common knot for like rock climbing. So I don't have any actual data for you, but it tends that the rope will break long before a figure 8 knot will, because it's double backed through itself.
Yep. Awesome. Yeah, cool. As long as you can show, sorry, I can't remember seeing that in your technical report, so I only just got to skim it this morning. As long as you show you're working out with that, that's fine. Yeah, I'm happy with the knots. It's just that as long as you're happy with the safety factors on the knots.
Yes.
Yeah, cool.
And
All
on
right.
again, on all of our knots, we made sure to have a long tail on the end, so the knots
Yeah, I can see
would
that.
have to physically
Yeah.
break. They wouldn't pull through.
Yeah. Yeah, cool. Awesome. And the retaining point, can you show me down the booster and just... I'm not sure I'll be able to see it, but
So the
yeah.
retaining point is 2 eye bolts on either side.
Yep, I can see those.
That have individual loops. So there are 2 loops here on the
Yep.
swivel that go to either side, so that this swivel is the meeting point between the 2. And so
Right.
that
Yeah,
distributes the load on that entire centering ring. Gives us
Yeah, cool.
both nice rigging control from this swivel, as well as holding on to the main structure of the rear part of the fin can.
Yep. All right. I'm very happy with that. So cool. All right. We'll look at the forward separation now. We'll come back to the eBay.
Okay.
So if you can show, we'll pretty much just go for that whole same process again. And shoulder's quite long, isn't it? That's for your payload, is it?
Yeah, so we had to expand it for a couple reasons.
Yeah.
One of the largest being, yes, payload space, and then also space for our main chute, which is the 144.
Yes, 144.
Yeah, cool. Yeah, if you want to just pull out the chutes the same way you did, I just want to see it all, make sure it all falls correctly. Yeah, that looks fine. Yep.
Again, this is our 144-inch main chute in 48-inch firecloth and 40-foot of Kevlar. This is looped, so the shock cord is connected down towards this separation point. The firecloth is connected down by this separation point, and the chute is connected closer, about 2/3 up the line, closer to the payload section.
Okay.
So a big point that was made for us in our ground testing, normally for the club in our L1 and L2 testing for younger members, we stress 2/3 and 1/3. But for this, jumped just a little bit closer with our parachute to our nose cone. So it's a little bit less than 1/3 away from the nose cone, the main parachute. It's a little bit closer just to really ensure that the nose cone upon ejection is going to pull it out. And that was in our ground testing.
Yeah, cool. And awesome. And the ground testing was successful. So you were talking, you had early separation on your test flight, but on your ground testing, it was all good.
Yes, it was successful on our ground testing.
Yeah, cool. And you're happy with the charge sizes?
Yeah, we are pretty happy with it. Exactly. We have a lot of room, like for all of our charges. We had an approximate charge, and we increased it by a good margin so that we have lots of pressure forcing it out. And so when we were testing it, it was very forceful in how it pulled the whole chute out of the thing, and I was very happy with it.
Yeah, cool. Just quickly on those lines, have you considered ways to ensure the lines don't stay tangled? In particular, looking at taping them up or like using some masking tape or something?
Yes. So when we didn't have an opportunity, just because of our schedule, to pack this exactly for a launch. And so when we launch these cords, we'll wind them up together so that they don't tangle on deployment, and we will tape them up with some light tape to keep them from getting tangled while the rocket is launching.
Yeah, cool. Awesome. All right, so I'm happy with that. We'll come back to the payload, but we'll jump back down to the eBay. So if you can show me the eBay, and you can remove it from the tube. And then show me the electronics and the internals.
Like I said, this upper body section is hard mounted using screws and rib nuts to
Yep.
keep it attached to the AV bay in flight.
Cool.
Um,
That's all right. Big screws. Nice.
yeah, we had it. Could you pull? Come on.
Just while I'm staring at it, the key switch is there. You're happy with the vibration?
Let me set it down real quick.
Can't think of the right word
Yeah.
there.
So we haven't had any problems with vibration as of yet, and we've also got a plastic spacer that's on the other side of this that's helping to lock it down, and just having
Yeah.
something that's acting as a crush washer to help with vibration.
Yeah, so if we, like he said, the other thing we've done to avoid the vibration is these are 90-degree key switches. And
Yeah.
so when they are armed, right now they're disarmed, which means they're in the vertical position, and when they're armed, they're in horizontal. So it would
Gotcha.
have to, and it has a positive lock in that direction. So it'd have to bend upward against the force to get all the way up. And the contact means it would have to get more than 45 degrees over to completely disengage. And so we've flown it twice with these key switches, and we haven't had problems with them. They're also meant for mobile and vehicle uses, and so we're fairly confident that due to that they are fairly vibration resistant.
Okay, brilliant. Cool. So the charge wells, are they 3D printed or is that?
No, so these are aluminum rocket junkie charge wells.
Yep, perfect. Cool.
That are bolted and then epoxied as well.
Yeah, cool. Your electrical connectors there, the blocks. They look
The
all right.
terminal
Do you have a charge there to show me how you prepare them to put them on?
We don't
No
have a
worries if you
charge,
don't.
unfortunately,
No.
but the
Okay.
charges are Firewire E-match charges, and we crimp either side of those charges
Yep.
with ring terminals, and then screw them into those ring terminals into the terminal block.
Okay, cool. Happy with that. Can you open it up and show me the electronics?
I'll take the other. So we have these connectors on either side so that we can completely disconnect this side of the terminal block. These
Cool.
XC30 connectors we've used for a while on other flights, but they aren't compliant. They have soldered connections, and so we won't be using those on the spaceport launch. We'll be using these crimped Molex SM connectors, which we got one or two from another lab, but we were waiting on a couple to ship to us, which they arrived today.
Cool.
So these connections, which this is the connection to the switch, they have a positive latching plastic lever here, and we're using 3-pin connections for live voltage and 2-pin connections for the charges, so that they're physically incompatible. So it's physically impossible to plug
in.
voltage
Cool.
into e-match.
Yeah.
That, of course,
That's
is
good.
along with doing things in the right, like following a procedure properly and having everything very highly labeled.
Cool. So using RC3?
Yes, we're using 2 RC3s. We've flown several rockets with them now, and we're very happy with how they perform. They're very simple to set up. and
Yep.
we've had very reliable flights with them.
Yeah, cool.
This one is our primary, and this one on the back, our second, is our auxiliary or secondary.
Yeah.
And they each have labeled wires going to either side. They're powered by these 2-cell 18650 batteries.
Yeah, perfect. Cool. I am happy with that. And your GPS at the top, is your GPS armed from the outside, or are you doing that before getting to the launch pad?
We're doing that before we getting to the launch pad for two main reasons. One, we had issues with getting a fix on GPS if we didn't arm it ahead of time. So giving the board the longest period of time to get a good fix on the GPS was key.
Yeah.
And the second reason is we have a very high milliamp hour 18650 one cell with it. And so we think it will last up to 8 hours on that one
Cool.
battery. We're not
Yeah.
concerned with running out.
Yeah. I was about to ask, will it last the long delays you're going to see on the launch pad?
Yeah.
But yeah, 8 hours is good. Yeah. If you're not flying within 8 hours, you'll be taking it back off the rod. So,
yeah, exactly.
Yeah, cool. I'm happy with all that. So all of those connectors are getting replaced with the crimp, are they? You said?
Yes, all of the 18650 connectors will be replaced with the crimped connectors.
Yeah, cool.
Except for this Dean's connector, and that's
Yep.
because this is what came stock on the battery.
Yeah, cool.
And so we didn't want
Yeah.
to. For one, at least for these off-the-shelf joints, we were very confident that they would be fine for the launch. And we didn't really have a good option for the specific gauge of wire these are using. So these will still be Dean's connectors.
Yeah, cool. All right. Okay. Cool. Happy with all of that. So I'm just going through my checklist first to make sure I haven't missed any. That's all good. Just quickly, back on the motor, I forgot to ask you, you've got that ordered? Have you got that in possession, or are you picking up on the day?
Yes, we actually have two of the motors already ready. That will be driving into Mexico.
Cool. Sorry, I missed that question as we were talking about the motors. The other one, which I haven't covered yet, which is probably under your answer about the decals, is your frequency and team number located on the outside of the tubes. What's your plan for that?
Like our center of pressure and center of gravity, we were intending on getting nice, like decal stickers, nice vinyl stickers, laser print stickers to apply to the different parts of the rocket.
Yeah, cool. So that'll include your frequency and team number
and our frequency numbers for both the GPS and if we have any communication on the payload.
Yeah, cool. Okay. All right. Happy with all that. So next, let's can you just show me the payload? With the payload, I'm just particularly looking at the safety aspects of it. So I'm not a payload judge.
So right now it's kind of gutted, but it's got 3 separations. This upper part will be an electronics bay. It's got a Raspberry Pi and various like temperature sensors and all of that. In the middle will be a cooling section, which will have some dry ice in it and some insulating, like rubberized coating on the inside of it. And then on the bottom of it will be the hydrogel brain. With the Raspberry Pi will have a accelerometer that goes from the top down to the brain to get our information.
Right. Okay. Yeah. Cool. And that's staying within the nose cone all the way through. It's designed to.
Yes. Yes, it is.
Yeah. Cool. Awesome. Yeah, I'm okay with that. That's all good. Cool. So yeah, attached was the word I was after. All right. think that's it for me. So I'm just triple checking. We talked vent holes, we've done all that. You guys got any other questions for me, or yeah? I'm happy with your rocket overall from a safety perspective. So,
I think we might have one question.
Yeah.
Yep.
I was the back of it. So the launching on the first day, is there just kind of a queue that forms once you get to the launch site? I know there's a bonus for being able to launch on Wednesday. Is that realistic if we were ready, that we'd be able to get that opportunity?
sorry, would you mind repeating that? The microphone.
Oh, no
just
problem.
came clear.
I know that
Couple
there's a
closer.
bonus on the first day. Is it realistic that if we were ready on that first day, we'd be able to launch, or is there usually a pretty long queue?
Honestly, I don't know. I haven't actually been to an event myself,
okay.
so and unfortunately, I won't be able to attend this one. We last minute had a problem over here, so I'm not going to be able to attend. But if you want to check, it might be just worth just putting a question up on the forum, maybe, and getting somebody else to answer. But yeah.
Got it. Thank you.
As far as the logistics of the actual event go, I'm not really sure. I'm here as sort of like an RSO, just doing safety checks and etc. So,
Got it.
yeah,
Got it.
yeah.
Do you
But
know
definitely
someone at the event
any
will go through
safety
the same
questions?
process that we went through today for the entire rocket? I know they will for certain aspects.
Yeah, so it'll be like, from what I understand, you'll have a flight safety check like you would at any launch. So it'll be exactly the same.
Got it. Got it.
Probably won't go into as much detail, so you won't you won't be asked to show separation, pull your chutes out, and all that sort of stuff because you're back ready to go. But it'll be exactly the same like you've experienced at other launches.
Right. Right. Thank you.
Yeah. Yeah. Cool. All right. Cool. So your next step is you need to upload your recording. If you've got instructions on how to do that. And I'll tick you off on this end, and I think that's it from the safety review. So, yeah, I think that's the last you'll probably be talking to me as well.
Okay, well, thank you.
No worries at all. Cool. Awesome. Thanks for your time.
Yes, thank you.
Very
Yeah.
much.
Awesome, guys. Good luck with your flight. Hopefully you go well. Cool. All right. See you later.